This week, astronomers are scrambling to explain what the James Webb Space Telescope just found behind 3i/Atlas. For most of the past year, Atlas was background noise, a known trajectory, interstellar, fast and unremarkable. It entered the solar system on a hyperbolic path, moving too quickly to ever return. Its composition? Inert. Surface activity? Minimal. Unlike Oumuamua or Borisov, it showed no signs of disruption, no anomalies. It was supposed to be boring, but it wasn't. 5 days ago, data analysts reviewing archived JWST calibration frames noticed something odd. A faint but stable thermal signature trailing Atlas, offset by just a few arcseconds. It wasn't visible in optical light, nor did any ground-based telescope log its presence. But in Webb's infrared spectrum, it stood out. At first, it looked like residual heat, maybe a smudge or background fluctuation, but the emission was consistent. It held its shape across multiple observations. And crucially, it was moving, not away from Atlas, but with it. That was the red flag. It wasn't dispersing like dust or gas. It was maintaining velocity. Speed matched. Pacing. At nearly 87,000 kilometers per hour, that kind of synchronization doesn't happen by accident. The signal was reprocessed over the weekend. What emerged wasn't a plume or flare, but structure. A thermal profile with uniform spacing, repeating intervals, and geometric regularity. This wasn't turbulence. It was pattern, rhythmic, deliberate, and persistent over time. No one is calling it artificial. Not yet. But internal documents now refer to it as the anomaly, and its signal has been independently confirmed by 2 infrared arrays in Chile and 1 space-based observatory in geosynchronous orbit. The most recent tracking update, issued just yesterday, shows the anomaly is still following 3i/Atlas, not gravitationally bound, not fading, and not behaving like any known fragment. The question isn't just what this is, it's why we didn't see it sooner. Because 3i/Atlas passed its closest approach weeks ago. Every telescope on Earth watched it. But this wasn't part of the plan. The object we dismissed as routine is now the center of the biggest mystery in deep space right now. And the clock is ticking. The signature wasn't faint. It was filtered. That's the first thing researchers realized when they reran the Webb data using custom calibration curves. The anomaly had been there all along, embedded in the deep field margins, masked by automated noise reduction and spatial smoothing. Not hidden, just dismissed. It took a manual review to catch it. And once they did, the signal became impossible to ignore. Infrared emissions don't lie. They tell you temperature, density, and motion. And this one broke all 3. The object trailing 3i/Atlas wasn't behaving like a natural satellite. It was too cold for an active body, yet too warm to be inert. Its thermal signature was precise, peaking at intervals of 11.2 seconds, with dips that followed a repeating cadence across all 3 detection bands. No known cometary process produces that kind of regularity. It wasn't rotating. It was pulsing. Webb spectrometer revealed more. The anomaly emitted narrow-band radiation centered at 10.3 microns, the region typically associated with silicate dust, but here it was shifted, slightly, repeatedly, like something modulating the frequency. Doppler drift couldn't explain it, nor could thermal distortion. The pattern looked artificial, or, at the very least, engineered. That's when comparisons started, not to other comets, to machines. Thermal engineers at JPL were quietly pulled in to review the data. Their verdict: the emission profile resembled a managed heat system. Specifically, a radiative array, something designed to expel energy evenly across a surface. It's the kind of signature you'd expect from a spacecraft under controlled thermal load, not from dust, not from rock, and certainly not from an interstellar fragment. The pacing, too, was precise. Across 3 consecutive nights, the anomaly maintained a relative position behind Atlas within less than 0.015 degrees. No drift, no lag. At those velocities, even the slightest gravitational influence from the Sun, planets, or Atlas itself should have introduced deviation, but the anomaly held course, as if actively adjusting. Ground-based follow-up failed. The object remains invisible in all optical bands. No albedo, no reflectivity. It's either too dark to detect or designed to evade detection entirely. That narrows the list of natural explanations down to near zero. A debris cloud can't do this. A gas jet wouldn't hold formation. And fragments don't pace a comet for weeks without scattering. Whatever this is, it's not just following Atlas. It's escorting it. Internal communications from the Webb team flagged one phrase repeatedly: non-ballistic behavior. That's NASA speak for it's not moving like an object should. And in orbital dynamics, that's the line between a rock and a vehicle. Still, caution dominates the conversation. There are no public alerts, no headlines, just silent coordination across observatories and a quiet shift in tone. The Webb instrument team has reallocated observation windows. A thermal anomaly is now priority 1. The object has no tail, no coma, and no known signature in any other wavelength. But it radiates with precision, a fingerprint of something under control. Whether mechanical, biological, or something else, the laws of physics are being obeyed, just not as we understand them. The working theory? A structured body, possibly shielded, operating in tandem with 3I/Atlas, but not bound to it, moving together, but distinct, and right now still closing in, because the anomaly hasn't stopped. It hasn't changed course, and it hasn't turned off. The signal is growing clearer with each pass, the cadence more defined. It's not just a thermal echo anymore. It's a transmission pattern. The timeline isn't just tight. It's surgical. The first trace of the anomaly appears in JWST archival data from August 14th, captured during a recalibration scan of deep field mosaics. At the time, 3I/Atlas was already receding from perihelion, gliding outward past Mars's orbit. The comet had faded from public attention, but the telescope, always watching, caught more than intended. Initial review logs flagged nothing. The anomaly's thermal profile fell below automated detection thresholds. It wasn't until August 27th, during a reprocessing sweep by the NEI substructure group, that it was spotted, an energy smear, faint, structured, and traveling alongside a known interstellar object. By August 28th, the signal had been independently confirmed in 3 separate JWST datasets. No drift, no dispersion, just perfect pacing behind Atlas, matching its hyperbolic trajectory. That same night, the alert was elevated to level 3 within NASA's internal monitoring system, reserved for anomalous orbital behavior, not immediate hazard. The label, trailing thermal anomaly, possible non-Keplerian. The next morning, the European Southern Observatory received an encrypted request to reorient its infrared array in Chile. No object was disclosed, just coordinates. Observation windows were granted within hours, but ground-based scopes returned nothing. The object didn't reflect. It only radiated. August 29th, 11:52 Universal Time Coordinated. JWST captured its cleanest image yet. 5 consecutive exposures revealed the anomaly with increasing clarity. Same pulse interval, same trajectory, same offset. A structure emerged, not visually, but thermally, symmetric bulges of emission, tapering in at both ends. Uniform heat gradient. Not a cloud, not a flare, not noise. An emergency session was convened between the JWST Science Operations Center and NASA's Planetary Defense Coordination Office. The object was reclassified. Persistent thermal comover. Not a satellite, not a fragment, but something else. Its acceleration profile suggested stabilization mechanisms, invisible but implied. By August 30th, the Webb team had redirected telescope time for continuous observation. Webb isn't designed for rapid response, but it's precise. The object stayed in lockstep, not orbiting Atlas, not tethered to it, just close, controlled, intentional. Meanwhile, ESA's solar orbiter was queried for cross-spectral comparison. The result? No detection, which made the contrast sharper. Whatever this was, it only existed in the narrow infrared bandwidth Webb could see. Other instruments, even from orbit, remained blind. By August 31st, the anomaly crossed an internal threshold. It had now maintained synchronized motion for over 72 hours. No deviation. No decay. The chance of a coincidental natural alignment dropped below 0.002%. Statistically, the object was no longer a curiosity. It was a system. On September 1st, an unnamed engineer leaked a one-line message from a private Slack channel inside Webb operations. "This isn't a tail. It's a sentinel." That quote has since been redacted from all logs. As of this morning, the object has been in active lock with 3I/Atlas for at least 19 days. Observations continue, but the margin for coincidence has vanished. Whatever this is, it didn't just appear. It's been here, tucked in the blind spot of our most powerful observatories. The timeline is short, but the implications are long. Because if we didn't see it on August 14th, how many more went unseen before? What Webb saw next changed the conversation. On September 3rd, the telescope's updated calibration routines pushed the anomaly into clearer focus. Multiple image stacks were combined using a contrast enhancement algorithm originally designed for exoplanet transits. It wasn't meant for moving objects, but when applied to the trailing signal behind 3I/Atlas, it revealed something no one expected: edges. Not clean lines, nothing so cinematic, but regularity, repeating geometry. For thermal peaks spaced evenly along a central axis, two smaller nodes flaring out symmetrically, and behind them, a taper, as if the emission structure narrowed with distance. To thermal engineers, it looked less like a cloud and more like a spine. The dimensions, while still blurry, were measurable, roughly 200 meters end to end, with a central emission source stretching across 120. The heat gradient wasn't spherical. It was planar, like radiators. The temperature drop-off was linear, not chaotic, suggesting not only structure, but material. No known natural process forms a body like this. Even large outgassing events from comets or icy fragments scatter asymmetrically. Dust plumes are turbulent. Gas plumes expand unevenly. But this anomaly didn't expand. It held. Stable, narrow, directional. It wasn't ejecting mass. It was maintaining form. Further analysis showed heat flickering along the edges, not random but rhythmic. The signature match-phased energy discharge, a term normally reserved for controlled systems. Spacecraft, satellites, power arrays. But none of those exist out there. At least, not from us. One theory surfaced, briefly and quietly, that it could be a sail, a light-driven structure, harvesting radiation to control trajectory. But the orientation was wrong. The object wasn't angled away from the sun. It was edge-on, as if minimizing exposure. Others proposed a passive reflector, some ancient artifact drifting through space, accidentally matching Atlas's path. But reflectors don't emit, and they don't pulse. The heat distribution didn't just mimic structure, it suggested intention. Webb caught what appeared to be brief temperature spikes at precise intervals, too short for solar heating, too regular for chance. In machine diagnostics, those spikes would be status signals, handshakes, beacons. But this wasn't diagnostics. It was a cometary flyby. And yet, the deeper the data went, the more it looked like a system designed to be seen, but only by the right instruments. Notably, the structure stayed invisible to every non-infrared detector. Hubble saw nothing. Gaia saw nothing. TESS, even with a wide field, logged zero visual movement in the region. This thing, if it is a thing, is selectively visible, not cloaked, not hidden, just filtered, like it knew what to avoid. Webb's heat maps show no sign of combustion, no propulsion, no active jets. But the motion, the symmetry, and the persistent coherence over distance point to one unsettling truth. It's not drifting. It's navigating. Quietly. Precisely. Without revealing how. In the most recent observation, captured less than 48 hours ago, the anomaly adjusted. A shift of 0.008 degrees in relative pitch. The formation narrowed. The thermal profile compacted. Not a failure. A maneuver. It may still be natural. We don't have proof otherwise. But every new frame sharpens a picture that no longer fits in the boundaries of known physics. A structure is moving through the solar system, pacing an interstellar object, masked by glare, revealed only in infrared, and responding to conditions with intent. Whatever this is, it wasn't built to be bright. It was built to blend in. Until now. Here's the part that breaks the model, not just a story. 3. I/Atlas isn't local. Its speed, angle, and origin confirm it came from outside the solar system. An interstellar object, moving too fast to be captured, and too shallow to have slingshot around the sun. It entered from the direction of Lyra, crossed the plane of the ecliptic at a low inclination, and is now outbound, already past Earth's orbit, which makes the anomaly trailing it even harder to explain, because interstellar trajectories are unforgiving. There are no do-overs, no corrections. Once you enter a system like ours, you're at the mercy of gravity. Every motion has to be perfect. Even a small deviation can push an object millions of kilometers off course. But the structure behind Atlas is matching that path, precisely for weeks, holding formation across astronomical distances at a relative velocity of over 87,000 kilometers per hour without drift or decay. That's not just improbable. It's physically improbable without control. There's no known natural force that can do that. A fragment ejected during entry would lag behind, wobble, or scatter. A dust cloud would disperse, pushed by radiation pressure or solar wind. Even a solid companion would eventually deviate, affected by microgravity and inertial lag. But the anomaly is immune to all of it. Its path is so tightly synchronized that orbital fits show less than 0.004% divergence from Atlas's track. In celestial mechanics, that's surgical. The kind of precision only active navigation can maintain. And that introduces a bigger problem. If this object is interstellar, and its trajectory says it is, then it didn't just appear. It planned this. No probe, no fragment, no natural object maintains synchronized motion with a comet at this scale and speed without propulsion guidance or a deliberate approach vector. Which means this isn't just a formation. It's a route. Either we're looking at a phenomenon we've never seen before, or something just traveled light years to follow a path through our system. And it didn't miss. Speculation always follows discovery. But what happened this week wasn't speculation. It was escalation. On the morning of September 9th, an internal report from the Webb Science Operations Center used a phrase that hadn't appeared in previous updates. Artificiality cannot be excluded. For words, quiet, clinical, but once they entered the record, the tone shifted. Within hours, the report was elevated to NASA's chief scientist. A parallel memo was circulated to Planetary Defense Coordination Office, marked Request for Contingency Scenario Review. The object wasn't declared a threat, but its behavior, its silence, triggered something deeper than protocol. It triggered doubt, because the anomaly did something no one predicted. It moved. At 4:12 Universal Time Coordinated on September 8th, during what should have been a routine tracking window, the object deviated just slightly, a yaw of 0.02 degrees. Not random, not noisy. A clean vector shift over a 16-minute interval. The object realigned with 3 I/Atlas, maintaining distance, but not course. It was now flying offset deliberately, as if adjusting for observation. The shift wasn't large enough to cause panic, but it was impossible to model. No gravitational source nearby. No outgassing detected. No thermal spike. It simply changed orientation, a behavior consistent with maneuvering. At JPL, the orbital team ran the numbers again. The result, a course correction consistent with velocity dampening, not acceleration, just modulation. The following day, an anonymous source within NASA leaked internal communications to a closed astronomy forum. The messages were brief, technical, and restrained. But one stood out. It's not what it is. It's what it's doing. In that one line, the uncertainty crystallized. Because while the structure may still be natural, some ultra-low albedo fragment, some unknown outflow, the behavior isn't. No known non-biological body modulates its position across tens of millions of kilometers in lockstep with an outbound comet, especially not one from interstellar space. By September 10th, JWST's entire observation block was reconfigured to extend infrared tracking. The anomaly is now a Class 2 target of interest, a designation typically reserved for transient phenomena like supernovae or gamma bursts. But this one is explosive. It's methodical. Outside of official circles, astronomers are beginning to ask what no one wants to ask publicly. If this is artificial, who sent it? And more urgently, why now? Because this isn't just about detection. It's about timing. 3I/Atlas wasn't the first interstellar object, but this is the first time a companion has been seen. And not seen by accident. Seen precisely when our most advanced infrared telescope happened to be looking. If the object wanted to go unnoticed, it failed. If it wanted to be seen, it succeeded. The reality is more unnerving than fiction, because for now, there is no signal, no message, just motion, deliberate, consistent, controlled motion, not toward Earth, not away, just alongside, as if watching, or waiting. The latest calculations from the Jet Propulsion Laboratory show no trajectory intersection with Earth. The anomaly will pass at a distance of 21 cents, safely distant by planetary standards. But orbital proximity isn't the point. This isn't about collision. It's about presence. An object, unexplainable by current models, entered our solar system and is now executing non-ballistic motion near a known interstellar comet. It doesn't respond to radio. It doesn't emit invisible light. It doesn't scatter or degrade. It just follows. And now adjusts. Speculation has become protocol, and protocol is edging toward alarm. Because if this is something, it's not new. It's just newly seen. This isn't the first time we've been caught off guard, but it might be the most revealing. The structure behind 3I/Atlas wasn't discovered when it arrived. It wasn't discovered as it passed perihelion. It was found after hiding in thermal data from a telescope, not even looking for it directly. And there's a reason for that. The same reason astronomers dread this time of year. It's called the holocheck effect, a known observational blind zone caused by the sun's brilliance. When an object approaches from within 30 degrees of the solar disk, optical telescopes on Earth can't see it. The sky is too bright, the contrast too low, and no matter how powerful the lens, sunlight overwhelms the frame. That blind wedge carves out a chunk of sky we simply can't monitor. Between August and early September, that's exactly where 3I/Atlas and its thermal companion pass through. Invisible, undetectable, even wide-field surveys like Pan-STARRS and ZTF are forced to look elsewhere during these solar weeks. And the James Webb telescope, orbiting beyond the moon, has its own restrictions. It can't point too close to the sun, either. It relies on deep field alignment. And luck. That luck is the only reason we saw the anomaly at all. Had JWST not been recalibrating its infrared targets, the object would have slipped past, undetected, unrecorded, unexplained. Another interstellar past dismissed as unremarkable. Another mystery buried in daylight. The holocheck zone has haunted astronomers for decades. It's the same blind spot that delayed detection of comets like C/2025 R2 SWAN. But this isn't just about comets anymore. The new threat isn't mass. It's method. Because now we're not just worried about what's in space. We're worried about how it enters. The solar glare doesn't just block small rocks or faint ice bodies. It can hide structured thermal signals, coordinated formations, things with trajectories, intent. And as this week proves, even our best instruments can miss them until it's too late to track them properly. Every discovery like this one isn't just a wake-up call. It's a record of how blind we still are. No one wants to say it out loud. But the question is on the table now, behind closed doors in encrypted channels, between colleagues who normally never speculate. What if this isn't a fragment? What if it's a probe? The idea has precedent, not in confirmation, but in theory. In 2018, Oumuamua sparked a similar debate. A fast-moving, oddly shaped interstellar object with no coma, no tail, and a sudden, unexplained acceleration. Harvard astronomer Avi Loeb famously suggested it could be artificial, an idea dismissed by many but never disproven. Back then, the response was skepticism. This time, the silence feels different, because the structure following 3I/Atlas isn't just fast. It's stable, and its motion isn't random. It's calculated. It behaves more like a tracking beacon than a rock. And that's what's setting off quiet alarms. The structure doesn't send signals, at least not in radio, X-ray, or gamma, but its thermal profile pulses in a rhythm, not constant, not chaotic, just regular. Some believe it could be a thermal modulation system, venting heat to maintain internal temperature, but others see something else. Timing, the idea that the pulses are deliberate, encoded, or responsive, that maybe this isn't just a machine operating, but a machine observing, waiting. If it's a probe, it isn't broadcasting, but it could be listening, or worse, recording. And the implications stretch far beyond astronomy, because probes mean missions, missions mean origin, and origin demands intent. If this object was sent, even centuries ago, from a system light years away, then it was aimed, not just into our solar system, but into this specific corridor, the one that intersects Earth's orbital plane, the one timed perfectly for a JWST window, the one we almost missed. There's no evidence of contact, no message, but presence in itself is a message. It means we're not invisible, not alone, and not the first to look outward. Right now, it's still just a question, but it's the one no one can ignore anymore. What if this isn't just another interstellar anomaly? What if it's the first to notice we're here? The window is closing. On October 29th, 2025, the anomaly trailing 3I/Atlas will reach its closest point to Earth, just 0.19 astronomical units, roughly 28 million kilometers. That's inside the orbit of Venus, closer than Mars ever gets, and closer than any confirmed interstellar object has passed in recorded history. But the danger isn't impact. It's what we'll miss if we blink. At this distance, radar detection becomes possible, not guaranteed, but within reach. Ground-based radar systems like Goldstone or China's FAST facility could attempt active ranging, but the object's low reflectivity and narrow emission profile make it an elusive target. Webb will still have the clearest shot, but time is limited. It's already rotating toward its next field campaign. The flyby offers a brief moment of high-resolution clarity, a sliver of opportunity to capture structure, emission drift, or movement changes before the object recedes. Because once it's gone, it's gone. The anomaly will accelerate out of the inner solar system at over 85,000 kilometers per hour. By mid-November, it will be too distant for meaningful analysis. The current projection shows the anomaly maintaining formation with Atlas through closest approach. No deviation, no drop-off, and that's what concerns mission planners the most. It's still holding, still following, still silent. The geometry of the pass also matters. On October 29th, Earth will be slightly above the orbital plane, allowing for a better observational angle, but only for a narrow window. Atmospheric distortion, timing errors, or interference could blur critical data. If the object makes another maneuver, even a subtle one, it could alter our entire tracking capability. And that leads to the final variable, fragmentation. If the structure breaks up, if it separates, if smaller bodies diverge from the main heat signature, we may not see them in time, not because they're dangerous, but because they're data, lost information that could have rewritten what we know about interstellar visitors. This pass isn't just a cosmic event. It's a test of our readiness, of our precision, of our ability to record something we were never meant to see and may never see again. What do you think? Subscribe for more about 3I Atlas.